Let's talk about polynomial long division. So what we're going to wind up talking about is how would I divide this big long polynomial by this smaller polynomial. And to do that, we're going to use long division. So let me back up a second and look at what you should already know how to do, which is long division with just plain numbers. So do you remember long division back in elementary school where you had to take let's say we took 3,642 divided by 17. So that's just a fraction. So let's write it as long division. All right, this means 3642 divided by 17. All right, so we're gonna divide 17 into 3642. Okay, so you ask yourself what I do is I say, well, 17, does that go into 3? Does it go into 3? No. Well, does it go into 36? Yeah, 17 goes into 36, not evenly, but if I multiply 17 by 2, I get 34. That's the closest I can get just using 17. And then I subtract that away. 36 minus 34 is 2. And then I bring down what's left, the 42. All right, and I repeat the process again on this line. So to ask myself, how do I turn a 17 into a 24 using multiplication? Well, I can't get exactly 24. The closest I can get is a 1. 1 times 17 is 17, and we subtract that away. So 24 minus 17, that'd be a 7. And then I bring down the 2. Then I repeat the process again with the 72, right? 17. How many times can 17 go into 72? 4 times. This is as close as I can get. 4 times 17 is 68. And then I subtract. 72 minus 68 would be 4. And at that point, I'm out of numbers, right? I'm out of numbers. I brought down the 42. I brought down the 2. There's nothing else to bring down. I just left with a 4, and I can't turn 17 into a 4 multiplying by a whole number. So that's it. I get 214 plus a remainder of 4. Or remainder 4. I remember in elementary school they said R4, which is ridiculous. So here's what this means. It means that if I take 17 times 214 plus the remainder of 4, I should get 3,642. That's how division works, right? This times this should give you, this times your answer should give you what was underneath there. So let's just humor me for a moment, and I'll type it in my calculator. 17 times 214 plus 4. Right? I get 17 times my answer up top, which is called the quotient. I get this much, and then if I add the remainder back to it, I get 3642, which is what I should come up with. All right. So let's apply this. I always look to myself, how do I turn 17 into this number using multiplication, and then I subtract. And I just repeat the process until I get down to a remainder, and then I would write my answer like this. So let's look at one like what we started with. So let's turn x plus 7 and see what would I multiply x plus 7 by to get this. That's what we're going for. What times x plus 7 would give me this? So I do this just like in long division, but here's the trick. I'm just going to look at and see, how do I turn the x value into this front x value? All right, I'm not going to really, this plus 7 business just kind of follows me along for the ride. And all I'm going to compare is the x and then the first term. Okay, so how do you turn an x into x cubed using multiplication? X times x squared gives you x cubed. I'll put that right there. Oh, notice, see how the powers go in descending order? X cubed, x squared, x to the first, and then no x, x to the 0. So you've got to have that. You've got to have this in descending order. All right, so I have that, so that's no big deal. Okay, so x times x squared is x cubed. I got to multiply over here too. X squared times 7 is a 7x squared. Okay, now we're going to now we're going to subtract. That's what we did in long division. So x cubed minus x cubed cancels. This is what you want to happen. 4 minus 7 is a negative 3x squared. And just like in the long division I did a second ago, where I brought down, I subtracted, and then I brought down what was left, I'm going to do the same thing. I'm going to bring down what's left over. Then I repeat the process. How do you turn an x into a negative 3x squared? I'd multiply x by x to get the x squared, and I need to multiply, there's a 1 in front. 1 times negative 3 will give me the negative 3. So negative 3x is what I would need to turn this into this. So negative 3x times that would be negative 3x squared. Now negative 3 times 7, negative 3x times 7 is a negative 21x. And we're subtracting here. So negative 3x minus a negative 3x cancels to 0. Negative 18 minus a negative 21. Be careful with your signs. If you subtract a negative, it's like adding. Okay, so 18 plus 21. Negative 18 plus 21. Okay, so if we combine those together, you get 3x. You get 3x. So bring down the 24. Repeat the process over. How do you turn an x into a 3x? You multiply it by 3. 3 times x is 3x. 3 times 7 is 21. Now we subtract. 3 minus 3 cancels. Notice how that canceled every time. That's what's supposed to happen. 24 minus 21 will give you 3. Now I can't turn x into something that doesn't have an x using multiplication. Notice how I've run out of space up here. So this is my remainder. This is my remainder. So here's the idea. If I take x plus 7 and I multiply it by my quotient, x squared minus 3x plus 3, and then I add the remainder, I will wind up with that guy right there. Now I don't have to do this every time, but I want to show you that this works. Okay, x times x squared. Let me use a different color. So if I take x times x squared, I just distribute an x is what you're doing. You get x cubed. X times negative 3x is negative 3x squared. X times 3 is positive 3x. 7 times x squared. 7 times negative 3x. 7 times 3. Plus 3, plus the remainder. So x cubed. So you got negative 3x squared, positive 7x, being plus 4x squared. We got 3x, negative 21x would be negative 18x. And 21 plus 3 is 24. Look at there. Same exact thing as what was under the little bracket here. You don't do this every time. It's just that I want to explain to you how you can check your work is you multiply this out and see if you get the original. Okay, so this is the idea. So that's how you do long division using a polynomial. Let me show you one more. Let me show you one, or let's do a couple more. Let's do a couple more. So I've got another one here. Let's take x cubed plus 4x plus 8 and divide it by x plus 5. We're going to divide it by x plus 5. So x plus 5 is on the outside. X cubed plus 4x plus 8 is underneath. Now, I shouldn't have drawn it so long. Remember what I said earlier? Where the powers, it goes from x cubed, x squared, x, and then no x. You have to have this descending order. Does that happen here? No. There's x cubed. There is no x squared term. There's an x to the first, and then x to the 0, or no x. So to make sure this all lines up nice and evenly, all right, so I got to make sure everything lines up. I'm going to rewrite this as x plus 5, x cubed, plus 0x squared. So I'm going to put a placeholder in there for the x squared, plus 4x, plus 8. Now everything's going to line up whenever I start doing my long division. All right, if you don't do that, you'll probably screw up. Okay, so there's one trick of the trade, so to speak. All right, so you turn an x into x cubed by multiplying it by x squared. So x times x squared is x cubed. X squared times 5 is a positive 5x squared. We subtract. x cubed minus x cubed cancels. 0 minus 5 is a negative 5 x squared. And bring everything else down. How do you turn an x into a negative 5x squared? You need to multiply it by negative 5, and you need to multiply it by x. Negative 5x times that's a negative 5x squared. Negative 5x times 5 is a negative 25x. And we're subtracting. So 4 minus a negative 25 is like saying 4 plus 25. You bring down the 8. How do you turn an x into a 29x? Multiply it by 29. 29x, and 29 times 5, I guess it'd be 30 times 5 would be 150. So I think it'd be 145, just to make sure. Yeah, 145. And we subtract. 29 minus 29 cancels, which is what should happen every time. 8 minus 145 would be 8 minus 145. That would be what? Negative 137. Negative 137. Right? 8 minus 145? Yeah, 37. 137. So my remainder is negative 137. So recall that the idea is that x plus 5 times this right here plus the remainder will equal this right here. So let's try that just to check. And we're not going to, you don't have to do this every time you get an answer, but I'm just double checking my work. That should equal what I have underneath here. So let's see, everything you're going to distribute the x to everything. Negative 5x squared plus 29x. Then everything gets multiplied by 5. And don't forget the remainder that we're going to subtract away because it's negative. We say minus. So if I put everything together, you got x cubed, x cubed, 3x x cubed, and the negative 5x squared, positive 5x squared cancel. 29 minus 25 is a positive 4x, and 145 minus 137 should be 8. And looky there, that's exactly what we started with. X cubed plus 4x plus 8. So, okay, so let's try one more. We got this one written out. And we are going to take x plus 2 and divide that into here. So remember what we do. We say x plus 2. How do you turn x into x squared? X times x is x squared. X times 2 is 2x. Oh, notice it goes x squared, x to the first, and then no x, so there's no gaps. We subtract. So now x squared minus x squared cancels. 3 minus 2 is 1, or just plain old x. Bring down the 2. How do you turn x into an x? With a 1. Positive 1, so you say plus 1. So now x times 1, 2 times 1. Oh good, looky here. No remainder. X plus 2 times x minus 1. So this is your answer, right? But I can double check. X plus 2 times x plus 1 equals this right here. Be x squared plus 2x plus 1x plus 2 is x squared plus 3x plus 2. So here's the deal. If your remainder is 0, then this is a factor of this guy right here. You have found this is a factor of what you're dividing into. If your remainder is 0, then this is a factor of this.